national educator.
Hello and welcome. My name is Teacher Michael Oko, and today we're going to revise physics. Our topic of discussion today is gas laws. Now, under gas laws, a learner is expected to understand the laws that govern ideal gases. Ideal gases are perfect gases that obey such laws. A regular gas may not fully obey the gas laws. Now, today we have selected a set of questions that we're going to act as our sample questions in this revision. While answering this, I want us to try and expand it to be able to infer and answer next questions from what we have here. Now, very first, I want us to look at our first question today. Our sample question 1 reads that an air bubble expands as it rises to the surface of water in a deep pond. State the cause of this given that the temperature remains constant. Now, learner, when faced with a question like this, there is a bubble. Imagine a bubble of air inside a pond. Now, as it rises to the surface, it is observed that its volume increases. One ought to ask himself that what is really happening? What could be responsible for the volume that makes it small at the bottom of a pond and bigger as it comes to the surface? Now, the strategy that you need to answer such question are: how does the volume of a given gas vary with pressure? And how does the depth of water in a pond affect the pressure? Now, the pressure in liquids is dependent in the liquid density and the depth of that liquid. That would mean at the very deep part of the pond, at the bottom of the pond, the pressure there is high. As the bubble comes to the surface, the pressure reduces. Now, when you then need to understand the relationship between the volume of the bubble and the pressure on this bubble. This relationship is given in our knowledge. The knowledge we have is on Boyle's law, which states that the pressure of a fixed mass of gas is inversely proportional to its volume, provided that the temperature is kept constant. Now, when a quantity is inversely proportional to another quantity, it implies that when one increases, the other one reduces. So therefore, if the pressure of water reduces as the bubble rises, then the volume of the bubble should be expected to increase. Inverse proportionality. That is why we have an answer to this question as the bubble rises to the surface, the pressure on it is reduced. Its volume will therefore be increased. Now, this is a question borrowed from Boyle's law. A learner needs to understand the Boyle's law, which gives us for ideal gases, the relationship between the volume of a fixed mass of gas and its pressure when the temperature is kept constant. Now, looking at our next question, our sample question number 2, it reads, in an experiment to verify Boyle's law, the temperature of air in the container is kept constant. State the other quantity which is also constant. Now, from the statement of Boyle's which we stated, the temperature was said to remain constant. But what else must remain constant for Boyle's law to be verified. Look at the strategy for this. In your strategy, you need to recall the statement of Boyle's law.